que terminado, lo vamos conociendo todo, aquí venimos a direccionar. Vale, hacer networking, ahora mismo. Por favor.
Alex, mira a ver si se ve en directo. El doble de lo que queríamos. Y vamos las dos formas. Y cuando está hecho de las dos formas, lo presento. Esto va un poco lento, a lo mejor no deberíamos ir dos platos. Como yo decía, era así. Pero lo sé, esto es mucho mejor. Si me lo hubiese dejado hacer, lo hubiese hecho la mitad de tiempo, que se acaba. Si deja adelante no.
Si no, ponerlo para allá, ¿vale? Si quieres, pasamos ahí. Hay una silla aquí. Ahí. Esta vez yo, ahora os voy a dejar con Ilian, que va a dar una charla en inglés muy interesante de HTTP2. Ilian es ingeniero en Light Rail, ¿vale? Y Infrastructure Lead, ¿vale? Y es un tío importante, aparte de que sabe un montón, y nos va a enseñar esto que ha quedado en la presentación. Así que un aplauso. ¿Puedes quitar el proyecto?
¿A dónde? ¿Por ahí? Ya está bien. Mi castellano no es así de bueno, entonces yo voy a hablar en inglés. Lo siento mucho. So, let's get started. My name is Ilian. I'm working for Library. This is a USA-based company in Los Angeles. We have a few offices around the world. I'm UA infrastructure lead for our office right here in Madrid. It's one of the biggest in the company. And today I will talk about HTTP doing quick protocols and also how can we optimize the web stack for HTTP2 era. Okay. And of course we have to start with a question: why do we need a new version of HTTP protocol? What is wrong with the existing version of the protocol, which is 1.1? There is nothing wrong with the protocol. It has been used by Global Information Initiative since 1990. It's very simple protocol. Browser send a request to the server, and server response. One request, one response. Nothing complex. However, the things have changed drastically since the time it has been invented, and now we don't have only one request and one response. We have a lot of requests and a lot of responses. According to HTTP archive, for the top 100 sites, till 1st of April 2015, there are about 100 requests, and the average size of a page is 1.4 megabytes. So on practice, this just doesn't work. And because it doesn't work, we need to fix those issues, which HTTP 1.1 has. What are those issues? There are too many. I will mention only 3 of them. The main issue is that the protocol is very latency sensitive. There are optional parts like HTTP pipelining, and specification is huge. The original specification has been divided in 10 different RFCs. It's not easy to be implemented. There are caveats. You have to, if you want to create a parser for HTTP, you have to be very careful with string delimiters and other things. There are more like poor implementation, crappy proxy servers, and so on. For today's application, the main constraint, according to performance, is the latency. First page load is latency bound, as we all know. And this is the main constraining factor. When you start optimizing a page as web developers, you have to start with and consider what is the latency. How important it is, we can see on this chart. Here, it turns that here on the left side, take a look at this. If you have connection at home about 5 megabits for daily browsing, it's pretty enough. I'm not talking about streaming video or downloading huge file. I'm talking about daily browsing. This is, if you have like 6 megabits, 7, 10 megabits, it almost doesn't matter. The latency, it almost doesn't matter. If you have, however, like on the chart on the right, if you decrease the round trip time for 20 milliseconds, the page loading time decreases with 500 milliseconds. This is how important it is. So, if we have issues, we should find a solution, right? And what could be the solution? Maybe HTTP pipelining. HTTP pipelining has been invented for a purpose to get the constraint of one request and one response and to achieve multiplexing. As we see on this, without pipelining, one request, one response. With pipelining, we have 3 requests at the same time, and the server is returning 3 responses. Okay? It turned that this is not the right solution. And why it's not a solution? Because by specification, the server must send the responses in the same order that requests were received. What that means? This means that the entire connection remains first in, first out, and end-of-line blocking still can occur. In practice, imagine that the browser sends 3 requests. One is for HTML and for CSS, and the first one is a request which requires a heavy database query. What will happen? Despite the site, the server can serve the JavaScript and CSS file immediately. It should wait until the heavy database request finishes. So there are more issues like buggy proxy servers. So as a result, in most browsers, HTTP pipelining is disabled or not implemented at all. And browsers achieve multiplexing by opening multiple connections to the servers per domain. There used to be 2 connections per domain. Now most browsers open 6 connections in case of IE8. This is not the right way to achieve pipelining. First of all, neither the right way to achieve multiplexing. So what developers as a creative people, of course, they develop workarounds for all those years. And there are many of those, like creating image sprites. You combine multiple images. I think Most of you should be very well aware of those. So when you create or optimize your site, you have to apply them. Image sprites combine all your images in just one huge image on the price of consuming memory in the browser. Sharding, like instead, in order to avoid the limitation in quotes of 6 connections per domain, you serve your resources among multiple domains. You inline resources, for example, you bundle your JavaScript, CSS files in the page or SVG, like base64 encoded, which is a huge overhead, but it avoids requests to the server. You can concatenate files on the backend, for example, with Webpack or with Grunt, with whatever. If you can do that. If you can't, what you do is to calculate those dependencies on the client and use Congo service. In Liferay, we do this one because we can concatenate files on the server. We use Congo services. Reloading resources is a very common optimization. While the user is idle, for example. Reducing cookie size because HTTP 1.1 is very verbose protocol. The goal is to reduce everything which goes through the network. We try to reduce cookie size, or we just use cookie-free domains, just to avoid some cookies plus the headers of HTTP 1.1 may not sound like something huge, but actually it might be about 500, 800 bytes per request. We can use link instead of import or pack components into a pack document. This is workaround, but I did it in the past. In fact, the whole industry has been created to deal with website performance, but for a regular developer who wants to create his site and make it work as fast as possible, those are too much. Okay? And for that purpose, now it's time of HTTP 2. The protocol is based actually on Speedy, which has been presented by Google in 2009. And for all those years, the specification has been evolved more and more. And current status of HTTP 2 is that it's done since 18th of February 2015. Officially it's done, the specification is ready. We are currently on draft 17. It's on its way to be published. What is the goal of HTTP 2? It is to fix the issues in 1.1 version without breaking the web. Because the goal is not to break the web, all the protocols, HTTP, HTTPS, all of that, all headers, all methods which you use to send requests like get, put, whatever, they still exist. And if you're regular users, they will probably won't mention that under the feed, browser switch it to version 2 of the protocol. There are two ways to switch. The first one is if we use the upgrade mechanism in HTTP 1.1. We use HTTP upgrade mechanism, but there is a problem with this one. This requires a round trip. So the browser sends request, a full round trip is needed, and then we switch to the next version of the protocol, which is bad. We don't want this. So in case of HTTPS, it's used application layer protocol negotiation extension, ALPN, which avoids this drawback. It uses the TLS mechanism to switch to the protocol, and this again avoids a full round trip. What are the features of HTTP 2 and why should we care about them? I would list some of them, maybe the most important. On the first place, it's a binary protocol. It's not text one. So if you use telnet to connect servers and check what's going on, you won't be able to do it anymore. This is a binary protocol. You have to use Wireshark or a tool like this to sniff the network. Because it's a binary protocol. It's if you're Node.js developer, for example, and you want to create parsers, it will be much easier than it used to be. It's a binary protocol. There is a header. You have to you may just skip some frames, or just to read the payload of the frame, and that's it. Frame is the smallest communication unit between the browser and the server. The browser is going to exchange frames, and each frame belongs to a stream. Right? And here is the important part. Streams are multiplexed with priorities. We can specify that a stream is higher priority than someone else. We will see an example after that. And there is something very important, which is now on the protocol level, server push. I'm sure most of you have done this many times before, because this is just the inline. When you put something on the page, you actually push something to the browser. It can be cached, but you actually push this to the browser. Now, this is on a protocol level. All that means that one connection to the server should be enough. This is the huge achievement here. Not 6 connections per domain, as most browsers do now, or even 8 or more. One connection per server. So it's much easier for the browser to optimize downloading the resources. As you know, opening a TCP connection is very expensive because of a feature called TCP slow start. We'll see some examples after that. And this is the main achievement. One connection to the server, not anymore. So let's take a look at those units and those protocol. And let's say take a look at the frames first. Frames, this is the frame format. It has length, and among those, I will emphasize those of its properties. It's a type of the frame and stream identifier. If there are 10 types of frames, and stream identifier says that to which stream the frame belongs. If there is a frame with invalid identifier, stream identifier, this is protocol error. 10 frames, as I said, for example, for data, it conveys arbitrary data associated with a stream. We have headers frame, which is used to open a stream and carries name, value, parts. We have, for example, this one, reset stream. The browser can say, I don't want to retrieve this stream, for example, this CSS or JavaScript, just terminate it. We have priorities, which specifies the priority of a stream. We have push promise. This is what notifies the peer endpoint that the server is going to push a resource, go away, window update, and so on. Those frames, as we said, belongs to a stream. Right? They are grouped in streams. And streams are actually a logical bidirectional sequence of frames exchanged between client, browser typically, it might be not browser, it might be Charla, for example, and the server. Okay. Here is the interesting part. One single connection may have multiple open streams. Like in these examples, we have 3 streams. 1, 2, and 4. And stream 1 carries a page HTML, which is a client request, and the rest 2 streams, they carry JavaScript file and CSS. Those are push promises. The server pushed because it knows that the browser will request them in a while. And take a look here. So we have different frames for those different streams, and everything is multiplexed. This is a huge advantage in comparison to what we used to have with 1.1 version. As I said, streams, they have priorities and dependencies. Each stream has priority, which is specified by the client, by the browser typically, and this priority can be changed runtime. Imagine that the user has opened a page and it starts to scroll down the page. It makes sense for the browser just to stop a stream, reset stream, which is in the top, and say, hey, I need those resources which are on the bottom of the page, because the user is just going to reach the bottom of the page. Or if you have a browser and you switch to another tab, then and imagine this is a tab for the same server. Now, what that means that the browser should request resources from the second tab. They will have high priority. A stream, as I said, can depend on another one. Here we have B and C, which depend on A. If we introduce stream D, it will B and C will depend on D stream. Headers, this is special. This requires special attention because, as I said in HTTP 1.1, headers are very verbose. The point is that HTTP 2 is stateless protocol too. And because it's stateless protocol, the client still has to send resources to the server, data to the server. But now, the headers in HTTP 2 are compressed. All those, you know very well those header values, for example, user agent, whatever, cookies, everything, this is compressed. Header compression is stateful, which means that we have one compression context and one decompression context for the entire connection. The algorithm is called HPAC, header compression for HTTP2. It has been especially designed or invented for the protocol. One of the earliest version of the specification, following Speedy, they were trying to use GZ. And it actually was a huge achievement because the compression was spectacular. But because of some evil beavers and attacks like crime and breach, that killed actually GZ. And Roberto Pione and the other guys, they invented another way to compress headers called HPAC. Server push also is something very, very important. We did that for years. As I said, as soon as you pack something to the page, like image, CSS, JavaScript, I'm sure all of you have done that. You actually did server push, but manually. Now, this is on the protocol level, which means that server preemptively sends resources to a client in association with a previous client-initiated request. On practice, imagine we sent request for index.html. But in index.html, there are multiple scripts, multiple CSS files, for example. And if the server is if the client is Madrid and the server is in LA, the request will go. Then it will go back. The browser will parse the page. It will see with the speculative parsing, it will see that there are script CSS files, and it will send a request. So it would be much cheaper if the server could push those resources to the client. Of course, this is not for free because there are caveats here, of course, because the client may already have those resources in the cache, and it can send a reset stream, so it will terminate those stream. But in any case, the data might be already in the network. This is still under consideration, but point is the client explicitly must allow it. If, like in Node.js implementation of HTTP2, there is a way to check if it supports server push or not, and you can push, otherwise you skip this. A client cannot push, of course, a browser cannot push nothing to the server. Can we use HTTP2 now? Those of you who have full control of your servers can start today, now, because there are plenty of server implementations. And when I say plenty, actually for C++, for Java, for Node.js, Haskell, Python, grab one and start playing with it. Some of them still don't support the latest graph, 17. Some of them they do. I really like server called H2O, which is a brand new server. It claims it's faster than Nginx. It supports the latest draft. Actually, it has been released in the same day they say that HTTP2 is done. What about the browsers? Internet Explorer supports HTTP2 from IE 11 on Windows 10 beta. Firefox has enabled HTTP2 by default in version 34. It used to be with a flag. Chrome supports HTTP2. Last time I checked, a few days ago, they didn't still support the very latest draft. This has been supported in Chrome Canary, H217. This is the latest draft. Opera, since it's now based on WebKit, it supports HTTP2 by default. And if someone knows anything about Safari, please let me know, because they don't say anything. I don't know. No one says anything about Safari. No one. This is very important. Currently, only HTTP2 over TLS is implemented in all browsers, like Firefox. Yeah, it's written currently. Only HTTP2 over TLS is implemented for the guys right there. Firefox and Chrome, they especially claimed, they announced that they will not support HTTP2 over not encrypted connection. Why? Because it turns that there are some bad, crappy proxy servers, middle boxes, and they assume that everything which goes over port 80 is HTTP, right? And they try to optimize, in quotes, the traffic. So to avoid this one, to achieve security, they just decided to serve HTTP only over TLS, over the encrypted connection. Our journey in the world of HTTP2 protocol finishes till here, but the story doesn't finish here, because the research continues. There are new protocols which are being developed actively. Quick protocol is a Google protocol. All of those, by the way, Quick protocol, HTTP, they are enabled by default in Chrome. Despite they are not ready, they are not official. Google and the other browser, they especially Google for Quick, they extensively check and get some performance usages and try to see how things are going on. So maybe you don't know, but I'm sure that most of you who already use Chrome, the traffic already goes via Quick protocol. So what is the important part here, and what is Quick? This is a natural extension of Speedy and HTTP2 research. This is also multiplexed transport protocol, but with one huge difference in comparison to Speedy and HTTP2, that it runs on top of UDP. It doesn't run on top of TCP. And because it runs on top of UDP, many of the out-of-the-box gains in TCP, they are not available. They are implemented on protocol level, like congestion control, security, and whatever they implemented on the protocol level. It's not TCP which carries those. Why we can't use HTTP over DTLS, which are two other protocols? Because HTTP actually provides stream multiplexing, and DTLS provides SSL quality encryption. Because roughly 4 round trips are needed to establish HTTP over DTLS connection. 4 round trips, unacceptable. And the goal of Quick is to perform connection establishment with 0 round trip time overhead. 1 trip time connectivity overhead, and the protocol has all the benefits of Speedy and HTTP2, but there is no head of line blocking in Quick. And when I say no head of blocking, in HTTP2 we also don't have head of line blocking, but this is on different level. Now we are able to multiplex request and response, right, with HTTP2. But what about TCP, the underlying protocol? Delay of only one packet causes the entire set of Speedy or HTTP2 to pause, because TCP only provides single serialized stream interface. In Quick, when a single packet is lost, only one stream is being delayed. And we can see that on the following picture. Here we have 3 streams with red, green, and blue color. We have lost a packet in the stream with red color. The rest of those are not blocked, which is a huge advantage. The server, the browser will continue to process the other streams. If we compare Quick with TCP plus TLS, we will see that the goal of Quick is to achieve, for repeat connection, 0 milliseconds round trip time. For new connection, 100 milliseconds. The current number for TCP plus TLS are usually about 200 milliseconds for repeated connection and 300 for new connection. So this will be a huge achievement, right? What about the encryption? It has been invented for a Quick protocol, and it's comparable to TLS with more efficient handshake. It has built-in replay attack and IP spoofing protection. Here is one very interesting feature of Quick, that it has so-called forward error correction, which means that imagine we have 3 packets from client to the server, 1, 2, and 3. On the price of 1 packet, which is sort of those 3, we can avoid resending 1 packet, which means 1 full round trip. Again, a huge achievement. For communication channels, they are not defined by IP plus port, but an ID. Practice, when you leave a Wi-Fi zone and you enter a mobile one, connection will continue. Okay. So this was the theory of the protocols. Now, what should we do if we want to optimize the web stack for HTTP2 era? When all of you, I'm sure you have built systems, you do also those optimizations which I mentioned before. What will change and what is important for us, since we have now HTTP2 and Quick? We can divide those in 2 parts. The first one is that we still have to optimize the content which is being served to the browser. And some of the things which we currently do will continue to exist. Like minimizing JavaScript, CSS, and HTML files. This, you have to do it on no price. You have to do it because the data which goes over the network is, as less data goes over there, as better. You have to minimize, compress, do all your best to minimize on the network. If you have images, when you serve images, if you don't have a process to remove the redundant data from there without compromising the quality, you have to do it. PNG Crush, for example, is a program. It removes the redundant part of the images without compromising the quality, and the results are quite spectacular. It might be 20, sometimes 30%, from 10 to 30% can disappear without compromising the quality. Optimizing the critical path CSS, this one you have to continue to do it. Removing the CSS which is not needed on the page, using, for example, tools like UnCSS, which how many of you know about it? UnCSS? Okay. You take a look on those. This is pretty neat. Actually, you may have, if you have, for example, Bootstrap, this is a huge file, but I'm pretty sure that no more than without knowing your sites, and can't say the right numbers, but usually you may need no more than 10-20% of it per page. So on CSS just strips the not needed CSS on the page, which is not being used. Pretty neat optimization trick. You may specify attack and setting for future expired headers to help the browser to cache those resources and not request them back. You have to see how this will work with server push. It has been not resolved on protocol level. We as developers have to resolve it on application level. And of course, we have to use HTML5 offline storage to store already downloading files. That's not something bad. If you have control on your TCP, on your server and TCP stack, which is highly desirable, you can achieve performance boost by, for example, setting the value of TCP initial congestion window to 10 segments. Currently, it's by default. If you have some old servers or you're not sure, check your operation system settings and change it to 10 segments. This is the initial congestion. This means when we establish a connection, this is 10 segments is about 14 kilobytes. So the best to render your page as fast as possible, it's desirable to send no more than 14 kilobytes of data, more or less. This will help to boost the performance. Check the initial congestion width. It used to be 4 segments. Since 2013, it's 10. You may disable slow start restart after idle. TCP has been designed for long-term connections, and many servers they have this feature. They will disable. They will achieve slow start restart after some amount of time. Disable this feature. Now it should be safe, but of course measure how that works for you. Check and enable if needed Windows calling, and consider to use TCP fast open. This works for repeat connection. This is a very neat way to open up TCP connection as fast as possible. Now, since we are in HTTP2 era, we may consider to remove some of those optimizations or workarounds. For example, joining files. This is the first candidate to remove from your build system for your optimization strategies. Just remove that. Serve all the files as they are with proper header, so they could be cached by the browser, but get rid of this as soon as possible. It's not needed. It is very bad actually. It breaks the browser cache. Terrible. Just get rid of this one if you can. Check how that works for you. Domain sharding, if you request resources from many different domains, disable that one. It forces the browsers to open multiple connections, which is not needed. The goal is to have just one per server, per domain. Stop link resource inlining. Just stop embedding CSS, JavaScript images on the page. Stop encoding them in base64 if you do. Get rid of this optimization too. Images, the same for them. Stop doing this one. It's much faster in HTTP2 if you compare with HTTP1. With HTTP2, it's much faster. Downloading multiple images is much faster now. So there is no need to create a huge image. Browser just only loses memory and other details which I skip for now. If you have combo services like we do in Liferay, because again we can calculate the dependencies on the server, disable that. Stop using that. Just serve your JavaScript and CSS as they are. And stop using cookie-free domains, because as I said, headers are now compressed. There is no need. Start with those optimizations. Check how does it work for you. It may depend on the server implementation you have chosen. Some implementations, like H2O, they are pretty neat. Some of them are still not so good, but things are going forward. And I think more or less is this one. Thank you very much.
Okay, so any questions in English, please?
I have one. Can this work with only with static files, or also with? Imagine you are going to pre-render something, or you are using handlebars or something like that on the server side. How the server knows when to push?
Yeah, this is a very interesting question. I can answer according to server. So I used the implementation on Node. And actually there is a way to check. When you create your server, there is a way to check if server pushes disable. So you can do that. You as developer can go and say, oh, okay, now those resources will be needed. So you can say explicitly push from API of Node.js, but server like H2O, you can set a header which is link, for example, that's a CSS link preload, and from the server behind H2O, and then H2O will serve this request to the browser. Will serve explicit. So there is a way to control. It's, for example, if you don't know, you can use all heuristics, like just study your users, what are they doing, and you can serve those resources. With server push, it's not quite clear how exactly this works. This is work in progress. We are just starting. As I said, the browser may have those resources in the cache. So, despite it will reset the streams, they may just went to a network buffer. So, this is work in progress, but you can control it from the API or from.
I have another question. Is on the headers. You said that all the traffic is in binary now.
Yeah.
So the browsers has to deal with some headers. I mean, I'm thinking about authentication tokens or something like that.
Yeah.
If it's in binary.
No, there are no changes here. You as developer, you will not change anything for it. All this is under the hood. You will specify all the headers as you do now, not change it.
Okay.
If you change something, this for me we will break the web, and we can do that. From developer point of view, not changes. Neither in the way you set headers, cookies, nothing will change. All this is being done under the hood. So no change here. Do it as you do it so far.
Yes, regarding the quick protocol, you mentioned that it is also encrypted, but it will be using the same PKA infrastructure that we are using currently. It's symmetric infrastructure.
Yeah, for the servers you mean.
For the server and for the client to
yeah,
check.
we will use the same. The encryption method is theirs. They invented it. Despite people who say you have to, NSA will be very happy when you invent a new encryption method. They actually do it. One of the smartest guys in the world, they have been working on this. The encryption protocol will be theirs. But to establish, so we will continue to use private certificates, public-private keys. There won't be change here. But under the encryption under the hood will be different.
Because when you enter the SSH world, it's also private key, but the format of the keys are different.
Yeah.
In this case, you will be using the same kind of certificates and private keys and based on X509 and so on.
I think that the last time I checked, the encryption method will be different. This one we have to check what is the current status. I think that's what I know, that encryption method will be different. But as far as I know, we will continue to use. This is changing over the time. So we have to check what is the current status. Quick protocol is one of the most is currently under development. It's not officially announced. Like there is no specification. There is specification, but it's internal for Google. It's only in their browser. It may never be as popular as HTTP2. Maybe someday HTTP will use instead TCP, UDP. So for the encryption, that's what I know, that it will be different. It will be their protocol, and how exactly this will work, we don't know. Currently, if you open the browser and you have an extension, Chrome, and you have an extension, I have an extension which shows which protocol is being used. There are no any changes. I can connect to Gmail servers as usual with the same certificate, with everything. HTTPS protocol, but the encryption under the hood is different.
Yes, but basically the key exchange negotiation is based on asymmetric keys, I suppose.
I think so. Yes, that's what I think
the
so.
second question, have you heard if also, not only in the field of HTTP browsing, but also in the case of file interchanging, and do you think also quick will be used on those fields like SSH initially began being unsafe for replace telnet, but then it became STP, then SFTP and so on. Do you think that quick, with all of these advantages, will be used
This is a hard question because I don't know about their plans. I don't know. At least this one has not been officially announced. Currently, the only place I have heard it's used, and it's used actually, is in the browser. For exchanging files for SSH, at least I haven't heard anything about it.
Because
Maybe.
it has a lot of advantages. You
Yeah.
said if you change URL, something like maybe a track that is sending signals about the position, and then if you change to a Wi-Fi zone and then whatever, the communication can.
Yeah, probably. I follow closely those protocols. At least I haven't heard that they can be used for SSH. Currently, the research is.
No, I meant that change to SSH. I think.
If you don't mind, we can continue in the beers or whatever. More people waiting. Sorry.
When you have a CPU ahead on your communication now, because Steam had one of those problems, because the amount of description took away timeout from the connection, but started to have a more higher consumption of CPU time, and also Speed had the problem of loading a lot of files on your computer, which led to a bloat of files on your computer, even if the connections were already stopped. You already got all the streams and you got a lot of preload that was already cutting your computer.
Yeah, so for the first part of the question, Google, when I think it was, I'm not quite sure, I think it was 2012 or 13, something like this, they enabled TLS by default everywhere. And they published official results that this increased CPU overload with 1 to 2%. So in practice, the things are not so scary. It increases the CPU, but it's not significant. For them, it was 1 to 2% only. So things are not so scary. The world is going toward this direction. There is no way to achieve it. TLS will be enabled in the future, but it's not so expensive to enable, according to them. For us, for example, our servers in Wi-Fi, which are in USA, HTTPS is also enabled. I haven't heard from our admins right there that we have some issues. It's more expensive, of course. You have to encrypt everything, but it's not so expensive.
You need to have split personality sites that will cater and be optimized for the HTTP1 and also serve a specialized browser version for someone that
that's a very good question. I actually thought about this a lot. So it depends on the application. There are not so many ways to achieve it. You have to serve everything as prepared for HTTP2, and if your application is pretty simple, today's browsers are very, 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 very smart. It's not like in 2006 or in 7. You may have, for example, 5 files, not combined in one, CSS or JavaScript files, and depending where as I said, performance is latency bound. You try to move your servers as close to your clients. It might be even that you left those files without combining them, the performance drawback may be insignificant, right? If you optimize them for HTTP2. And all those browsers, only actually IE less than 11 is not supporting HTTP2. So if you have users only on IE, let's say, there is no way for you. You can't use that. But if you have, it may turn that you may enable HTTP by default, or if you have control over your server, you can provide 2 different optimization strategies. Like you check if HTTP2 is enabled. If you have Node.js, check if the protocol is enabled or not, and concatenate those files with a combo, or just spit them to the browser without. But that's the situation. You have to choose one of those to use 2 strategies, or use the old one, HTTP1, if you have IE, or use HTTP2 if most of your clients are using Chrome and Firefox. If most of our clients, for example, for external network, for external users, they use Chrome and in Firefox. Most of our internal clients, who are with internal, I mean those who have intranets, they use IE. So I was like a UI infrastructure software engineer. I think our optimization strategies may be based on those two user segments. This is what I think. You have to decide for your users, for your application.
Excuse me. We have one here and one there, and it's over, okay? And then we continue in the view. Sorry.
My question is about streaming, WebSockets, and WebRTC. Okay? I'm trying to build in my spare time a small startup to create a video conferencing system. I need help, so if any of you has a spare time, let me know. Okay? So my question is, what do you expect about HTTP2 regarding WebSockets? I mean, because right now what we do is we change protocol and start streaming data. So you expect, for example, to prove all the WebSocket connections over a stream in HTTP2?
Yeah, I actually expect to be moved on speed. For example, YouTube. I recently read an article that the buffering on YouTube for streaming video decreased with 30% for most of the users. Since Google control both their servers and YouTube, they used Quick under the hood, and this is what I read, 30% less buffering for the clients.
Okay, so maybe this will imply a explosion on WebRTC.
Yeah, absolutely.
What I'm trying to use.
For Quick, for HTTP, there are plenty of servers, as I said. For Quick, Google released one server and one client, so you can test how does it work. It's not production ready. It's being actively developed. It will be in the near future. Start with HTTP2, since this is again huge advantage, and then keep an eye on Quick. This will be my.
If you want help, then you can do a small talk here and present your project and blah blah. So you make it known.
At the end of this conference?
No, for another day.
I had just used Twitter, so.
Last
Yeah,
one.
hi. What's the difference between how HTTP2 the user's connection and keep alive with HTTP1 connection?
Yeah. So when you say keep connection alive, in both cases the connection won't be closed, but it won't be closed. The connection will be alive. But here, the difference is not in shall we keep the connection open or not. The point is that with HTTP 1.1 you have about 6 connections. As soon as you open the browser and start running one site like those which we listed, you have 6 connections. And now the connection is open, but the connections are open and kept alive, but they are not effectively used. Opening a connection is expensive. TCP has not been designed to just open a connection and close it immediately, like to serve one HTML, one JavaScript file. The browsers are trying to balance among all those connections in HTTP 1.1 and to use heuristics to see which of those resources could be downloaded via what connection. And with HTTP 2, you have just one, and everything is multiplexed. So you open the connection, you don't lose time like with TCP, because it will be over HTTPS. Usually this is a three-way handshake. You need a round trip, and this is what you save with HTTP. But it will be it will be open. Your servers, if you control them, instead to see 10,000 connections, you will see, let's say, 100 or something like this. It will be a huge advantage, not only for the browser, but for your servers too.
Okay, so thank you very much, Ilya.